Hi everyone, my name is Johnny. I work as a solution architect for Red Hat, and today I thought that I'd show how we can run our application across different footprints. So this scenario I had in mind to demo is that, let's say you're a company or organization or an individual and you have some kind of an environment. It might be a data center, or you're running application in a cloud context or public cloud context. But the request comes in to move that application and running on another location, another footprint. Maybe it's an edge device running on another location like a train, a bus, or something like that, or a factory or a remote office or some kind of smaller footprint, if you will. So you don't have a full-fledged data center at that location. To do this demo, I used a couple of different components. So in the center, we see Openshift, or actually it's CodeReady containers. So CodeReady containers is an all-in-one installation of Openshift, and Openshift is Red Hat's enterprise Kubernetes distribution. And we are also making use of Ansible automation platform that we will make use to create the automation necessary to deploy our application out to the edge device. And the edge device is then a rel node. And on that node, we're going to make use of a couple of different components, one being systemd that manages the upstart of the operating system. And we're going to make use of Podman, which is the container runtime. And I'll also show some aspects of Red Hat Insights. As you can see, I have my environment up and running. So to the left, you see my web browser running Ansible automation platform, and to the right, you see I'm logged into CodeReady containers, our OpenShift environment. I do have a demo script that I will run, and I'll walk you through what's going on in the background. As you can see, I'm using my local laptop as a demo environment. So CRC there is CodeReady containers or OpenShift, and then Ansible is, well, Ansible. So first we are going to need an edge device. So I will create a virtual machine. So I'm just using a script to create a VM called Edge1. It's going to have 20 gigs of disk, 2 CPUs, 2 gigs of RAM, and it's going to be based on RHEL 872. And just to go through what the script does, so first we're going to create a new project called Minecraft. So our application in this demo is going to be Minecraft. I will also make use of HA proxy to front the Minecraft server, just to show that it can be a more complicated application. And then we're going to allow anonymous access to the registry so that our node can pull the image. This is more to simplify the demo. In a production environment, you would use some kind of authentication. And then we're going to create a build. So while I go through this, let's just kick off the script here. Let's see here. So now we see to the right that the project is actually created. We can also go into this here just to see that it's going to create what is known as a build config in a while. So first of all, we added the unauthenticated access so that an anonymous user can log in. And now we have created something that is called a build config. And a build config is basically an object that knows how to combine a couple of different components into a running container image. So in this case, we're using the Docker strategy, and it's going to clone from this GitHub repo and basically run a Docker build against that cloned content. So we are creating two Docker builds in our OpenShift OpenShift cluster. So the first one is then the HA proxy Minecraft, which is basically a HA proxy instance that tries to connect to a backend server, which is then Minecraft. So these two containers are now being built on top of the cluster. And then we're going to add a build hook. So this is a post commit build hook. So what happens is that when we trigger this build, it will call out to the Ansible Tower REST API to launch a job that is created in the Ansible Tower instance. So while those builds are running, I'm actually going to continue the script over here. So this is adding the the post commit build hook to these build objects. So the next time we create a build, at the end of that build, it's going to call to the Ansible tower instance to start that job. So just to show you guys how that looks, I'm going to log in my Ansible tower instance, and I'll show you my jobs. So what I have is that I have a template called push Minecraft HA proxy, and this job is what is going to be kicked off when we create or when we launch the builds in Openshift. So the builds are now done. So let's check one of these out. So we now have a container that has been built in Openshift. So we could pull this container image now to this environment. But let's kick off this build again. So at the end of this, we're going to see the post commit hook, and it's going to start the Ansible tower job that is going to deploy the environment. So if we go to build configs, we can go to the Minecraft server and we can click start build again. So now we can also follow along what's going to happen. So if we go to the jobs page, so again, on the right side, we see the build starting. So it's going to clone the GitHub repo down to the build environment. And then it's going to more or less do a Docker build to this content. So it's going to follow the instruction that is in that Docker file to produce a container image. And as the last part of that, before the image is pushed to the registry, it's going to call out to the REST API to start this push the Minecraft HA proxy Ansible job. Let's see here. Yep, we're good to go. So while this is running, I will log into what is known as Insights or Red Hat Insights. So if you go to cloud.redhat.com, Insights is part of the subscriptions of RHEL. So we can see systems that has been registered to this environment. And Insights represents Red Hat's approach to doing proactive support. So the background or the story around Insights is that someone looked and saw that in large degree of the instances when someone calls Red Hat for support, we were already aware of this challenge or problem. So someone other customer had this problem and we were already aware of it, and a fix actually existed. So someone came up with the brilliant idea of, hey, what about we proactively notifying our customer about this potential solution to their challenge. Just as a caveat here, if you look to the right here, we see the run curl command that is going to trigger the job. So if you go over here, we're going to see the job starting. And as you can see here, push Minecraft HA proxy is actually starting. Let's see. So we see here that, yeah. So it's gathering facts. And we see that it has found our virtual machine here, edge1.home.lab. So let's continue the discussion around Insights. So anyway, if you register your RHEL server to Insights, it will proactively notify you around known problems or issues that we are aware of at Red Hat. So it's going to be registered, and it's at some point going to show up in your inventory. So the basis for this demo was actually a blog post, so I want to just highlight that. So if you look at, if you Google for systemd and Podman, one of the first articles is going to be running containers with Podman and shareable systemd. So we're deploying to an edge device, which is RHEL, but we still care about things like, what if the VM crashes and restarts? How do we make sure that our container is up and running? And if you're aware of how Podman works, you would know that it is it's not running as a daemon, so it's daemonless. So how can we make sure that the container restarts when the VM comes up? So we're making use of systemd to do that. And this blog post goes through to how you can create a generic systemd unit file to deploy a container to a system. And that's what we're making use of. As we can see here, the job is progressing. So the first thing that's happened here is also that it's running a registration. So it's registered for an entitlement or a subscription. And once that's done, it's going to go towards the insights. So let's take a quick look at the playbook itself. And the playbook is really simple. So the deploy HA proxy here, what it does is register the machine, and I'm not showing that because I have passwords in that file. And then in the roles section is where it becomes interesting. So it's going to include the role. So this is where the magic happens, or magic, but anyway. So if we look at tasks and main, this is basically what is going on. So first, what happens when the system is registered is going to install the podman. And then it's going to do basically a Docker pull or podman pull against our Openshift environment. And if you see here, the apps-crc.testing, it actually corresponds to our URL up here in our Openshift environment. And then it's going to lay down these systemd unit files that will make sure that our container is up and running on the system. And that is basically what goes on. So very simple. Now we see that the Insights client has or is installing, and we should be able to, if we go to the inventory, we should be able to see that showing up now. And now it's progressing to the next step, which is then installing podman, as I showed in the playbook. But if we go back here and refresh the page, we should be able to see our node up and running or being registered. And there we go, Edge 1. Some more information on Insights. So the first information we do is some overview information. So facts about the systems, what type of capacity, memory, CPU, stuff like that. And then there's a couple of different sections that I'll quickly run through. So advisor is what it sounds like. If we have any advice for this specific system, which there aren't any as of now. The vulnerability tab represents security issues or vulnerabilities that we think is important for you to be aware of. So if we expand one of these, we can read some more information about that specific CVE. So this specific one is about cryptography in one of the packages installed in the system. And then we have compliance. So if there's any policy created for the system, if it's compliant to that policy you created, and we haven't created one. And patch represents if there's any other packages that might fix known bugs or issues with the system, we can find out more information about that as well. So this represents how we would long-term manage, because this demo is showing one machine, but what if we have 50 or 100 or maybe even thousands? So Insights allow us to proactively manage all of that. And we can also fix this. So if we would like to, we could select all of these and we could remediate with Ansible. And this would create a playbook that would have the instructions that would fix these issues on the system. Also, as part of the playbook, we deployed something that is known as, or we enable something that is known as Cockpit or the web console. So if we now log on to the Edge 1 server, we can actually manage the server through the web UI. So just to show you, so even if you're not you've been working with Linux for a long time, there's a way for you to manage the system through a UI. So this is just an example. You can show some performance metrics. How's the system behaving? What's the CPU and memory consumption at the moment? You can do access the logs of the system, and you can access these different log items. So you can do some basic troubleshooting and start understanding what's going on with the system. You can do also some network configuration. So let's say you want to configure the network in a certain way. Also, if you want to manage the accounts of the node, and also access the terminal of the system. And if we look at our job here, the job is actually done. So it has now deployed our container to the local node. So let's see how that looks. So if we do a podman PS, which is basically a Docker PS, we can see that the containers is up and running. And if we want to look at the systemd unit files, we can also find those over here. So if we check on services and we filter for Minecraft, you can see that we have our two systemd unit files deployed to this system. And as a last note, let's see if we can launch our Minecraft client to connect to this newly deployed server. Hit play. It's going to start the client. So my system is running low on resources at the moment, so it's taking a bit longer here. And we do a direct connect, and we see edge1.home.lab, port 80, and hit join server. And we are able to access our Minecraft server deployed to our edge device. And that is it. Thank you everyone for your time with this demo, and I wish you a good day. Thank you. Bye.